All right, we're ready for the next talk. And this is Gary Flake talking about how I learned to stop worrying and love the imminent internet singularity.
Okay, I guess I'm the comedic relief for this conference since we're normally talking about such applied things and useful things as programming language. I'm here to kind of take your mind off of that just for a moment. Basically, I think a good subtitle for the talk is actually listed here. Why I'm going to make a case for why I think right now, today, in this period window of time, it's perhaps the best time in the history of the universe to be a computer scientist, because basically there's a convergence of a lot of different things happening that are making for something like a step function in terms of the advancement of computer science. So let me give you a preface to this whole idea, and I'll just call this the backstory. Some of you may be familiar with the notion of the singularity, which was originally proposed by Werner Vinge and evangelized by folks like Ray Kurzweil. Basically, the idea was originally sort of proposed in science fiction, but as something that was perhaps credible, where at some point technology would advance where the rate of change sort of ramped up to what was called the singularity, where progress was happening so fast that beyond that point one could not predict what would happen next, because science and technology would start to look like magic. So this has been talked about in both optimistic terms, pessimistic terms, new agey kind of religion stuff. I'm not going to actually talk about any of that at all. This is just sort of the backstory. The argument for this, though, is kind of intriguing, and I'll use it as something of a metaphor. The argument for why the singularity will happen goes like the following. There's three basic core advancements that all add up to making the singularity happening. One is hacking human intelligence. So imagine somehow we can actually manipulate individual neurons and make people smarter. The second is nanotechnology. How can you do molecular scale fabrication of arbitrary objects? Third is strong AI. How can you make something with superhuman intelligence that's artificial? And the idea is that if you have a breakthrough in any of these things, it actually enables progress on the other. So if you have a breakthrough in nanotechnology, you can start hacking neurons, or you can actually start fabricating CPUs at the sort of level where we can have clock speeds that are orders of magnitude bigger than today, that sort of thing. Or if you hack if you make a breakthrough in AI, the AI may in fact tell you how to do these other things. Or if you hack the human brain to the point where people are getting smarter, or even hacking the human genome instead, that may result in making us smarter and get these things. So this is, again, I want to put the preface, these are intriguing ideas. It's more science fiction than science, and I'm just using this as an analogy. What I'm going to talk about is something that I call the internet singularity, which I'll claim is actually a little bit more grounded in reality, and but in some ways perhaps even more interesting, because we see some evidence of the changes I'm going to talk about even today. And the basic idea is that as the coupling between the offline world and the online world becomes deeper and richer, and as the ability to use that coupling to advance the state of our own knowledge and understanding and our ability to create complex systems that realize greater, more powerful applications, there is a snowball effect where these things start mutually reinforcing each other, and the state of knowledge that is put out on the web, the power of the applications that we build, all of these things sort of start feeding on one another. So, and also it's a kinder, gentler singularity. So let me make so the outline for the talk today is really I'm gonna make the case in 4 steps, and I have to apologize. The 4 steps that I'm going to talk about are things that are sometimes not given a lot of credibility, because they're often associated with buzzwords and things like that in internet circles. So I'm going to try to make it a little bit more rigorous and a little bit more, well, if not rigorous, at least a little bit more credible. I'll then make the case for how all these things add up to the emergence of the internet singularity, and then I'll make some claims about what this makes, what the impact is to computer science as a field and a discipline. So, making the case. Now, this is just part 1 of 4 for making the case. First thing I want to talk about is democratization and macroization. So this is something that all of us are familiar with. The general trend is that we see increasing capabilities of the hardware and the software that we're using in terms of, I think the easiest way of capturing this is saying that today's desktop is greater than yesterday's supercomputer. And one thing that's very interesting is about every 5 years or so, we see cell phones or handhelds catching up to what the desktops were from 5 years before, just because with Moore's Law and everything. So it's quite exciting to think about, the device that you have in your hand today, what it'll be capable of doing, 5 years from now. And also just doing a sanity check that, back in 2001, some of the properties in that cell phone were found in cheap commodity hardware. Now, it's not just about hardware. There's also democratization and macroization in some really key areas that really fold around digital objects, so content, commerce, and community. And I'll claim that there's a positive feedback that forms a virtuous cycle between these things. So let's talk about this in some detail. A lot of us are familiar with lots of different tools that people have been using for decades that facilitate desktop publishing. So we have Office, LaTeX, HTML, all these different technologies around images, movies, audio publishing software. Net everything, what all this adds up to is turning people who had been content consumers into content producers. All right, that's a pretty powerful thing because we've lowered the barriers of what it takes to be a producer of some form of content. And in fact, yes, desktop publishing is ubiquitous. I may not actually have any musical ability, but by virtue of the fact that software facilitates tagging and list creation and for like playlists, I can be contributing to the state of knowledge about music merely by expressing my taste in music. So that's the sort of thing that I'm talking about in terms of lowering the barriers to participation, or barriers to entry for participation. Second thing, democratization of commerce. We've seen over the past decade a dramatic decrease in the cost or the startup cost that it takes to go online and do business. So in the early 90s, you had to be a major company in some sense to afford the T1 line and all these other things to go online. Today, it's almost given away. So we have Yahoo stores, Office Live, Amazon. You can basically get a virtual, put up a virtual store in no time. And we're seeing the barriers to entry drop even more in that people who are participating in e-commerce don't even necessarily have to have a persistent identity. They can go for single transactions on eBay, or they can do P2P financial transactions over PayPal. All these different things are actually making for a much more fluid e-commerce marketplace. In fact, there's some subtlety here because we're seeing with things like RSS and AdSense and paid search all adding up to the capability of allowing individuals like bloggers, for example, of converting reputation that they have in one topical domain into traffic into their website, which they then convert into cash because of AdSense. So there's a really interesting thing going on here where suddenly someone can actually pay their mortgage by articulating an opinion. Democratization of community. Taking a look at all the different tools that we have, instant messaging, email, VoIP, all these things are starting to mature, in some sense converge. We also see a lot of interesting things going on into social networking. It's kind of, I feel a little bit negligent for not putting MySpace up here because that's kind of taken everyone by surprise as well. The little thing I have to put right here, this is at risk of making it sound like I'm doing a sales pitch for Match.com. I actually met my wife on Match.com 7 years ago, so I was an early adopter of that sort of technology. The point here is that the social networks and the connections that we are all used to making in the physical world are actually gradually becoming instrumented online in very profound ways. So our email exchanges, our instant messaging, all these things are actually starting to create a little bit of a mirror universe on the internet with respect to what our social networks are. So putting all this together with respect to democratization and macroization, we see today's amateur is getting more resources than yesterday's professional. So in all these different things, you just think about the fact that 20 years ago, if you wanted to write a book, your options for self-publishing were quite limited. Today, if you want to self-publish, it's eminently doable with free stuff, no less. the difference between the amateur and the professional is gradually diminishing. So, the obvious examples, taking a look at, say, blogs or something like that, where in fact some of the bloggers, particularly around topics such as politics and social commentary, are actually in some ways doing more interesting work than the mainstream journalist. We see that some of the new technologies around e-commerce, say, Overture's model that they pioneered with paid search and AdSense coming from Google and other things like that, are allowing individuals to gradually become bigger players because the startup costs are so low, and it creates a more fertile ground for innovation in some sense. So the implications here is that the distributions of creators is dramatically changing over time in structure. So that's something of a segue for part 2 of 4, power laws and long tails. So I'm going to bet that that a lot of people in this audience are familiar with the notion of power laws and long tails, but I'm going to spend a little bit of time just kind of painting the context just for completeness. To put it concisely, a power law distribution is best characterized by, let me give you one example. The canonical example is talking about the distribution of biomass in the world. Okay? And if you take a look at the number of big things that exist, big animals that exist in the world versus small animals and small creatures, well, there's a relatively small number of whales and elephants, but an enormous number of bacteria. And in fact, it's not just in the raw count of the number of instances of those animals. If you actually do a cumulative summation over the distribution and you weighed all the elephants in the world or all the whales, they pale in comparison to the mass of all the bacteria in the world, or all the algae, or whatever small creature, or all the beetles even. And this is typically characterized by this thing called a power law distribution, that if you use simple linear scaling on your axes, it looks kind of ridiculous because you have this huge spike on one extreme and everything kind of peters out over here. We also see power law distributions on the internet as well, with many of the core things that we calculate, like hyperlink, inbound and outbound counts. And so here's one little example right here. The number of pages that have a very small number of inbound links is enormous. Okay, so pages like my personal website fall into here. So there's a lot of real small players. There's a tiny number of pages that have actually an enormous number of inbound links. So that means that there's a small number of yahoo.coms and google.coms and msn.coms and sites like that. If you start looking, if you take the bottom axis right here and you change it to a logarithmic scale, well, this starts to look a little bit more understandable. And if you go the next step and make this logarithmic as well, then a power law distribution falls onto this onto a line when you have log axes, and so that's one of the defining characteristics of a power law distribution, because you can characterize it by this power law relationship, the slope of this line. So yeah, we see this on the internet all the time. Now, what's really interesting is that not all power laws, but some power laws have this thing called a long tail or a heavy tail, and there's a book that's coming out. I think it's actually just come out in the past couple of weeks by Chris Anderson. He's the editor of Wired magazine, and he's really sort of pushing this meme around long tails. The idea is sort of what I said with the biomass example. The idea of a long tail is that when you take a look at the tail and you add up its weight or its mass or something like that, it's bigger in the aggregate than the head. All right? Now, 20 years ago, mainstream journalism, the head completely dominated the tail. There was no tail, really. The tail consisted of newsletters, or maybe you wanted to call CB radio some sort of like the primordial broadcast or something like that. I don't know. But the head of the mainstream media or publications, if you will, completely dominated. Today, if you add up all the bloggers, all the podcasts, everything else, I think that there's a really compelling argument that the amount of contribution made by the tail of those participants actually adds up to more than the mainstream media. Now, you can finesse your definitions one way or the other and come up with an answer either way. We're on the close of the threshold of that tail actually being quite pronounced. A canonical example of long tails, and one that Chris Anderson often talks about, is music. And I'll use music as an example a couple times in this presentation. So Chris talks about there being a very few number of Britney Spears, the sort of artists that have massive influence over the charts and can dominate charts for long periods of time and for better or worse capture the attention of a lot of people. And there's a very small number of Britney Spears, but a massive number of unsigned performers with little or no record sales. And so when you think about what MP3 as a file format, what GarageBand as a recording tool, and all the other low-cost tools that allow GarageBands or people with no talent like myself to upload an MP3 onto the web, we're creating an opportunity for more participation. All right? And one reason why this has changed, that we actually find long tails, is that before the internet, the tail producers really had no reason to persist or exist or survive in some sense, to be visible, because there was no cheap, easy means for them to say, hello, I'm here, look at me. And now with the internet, that becomes very easy. They can create a website and upload their MP3 virtually for free. Not virtually for free, literally for free. So now, of course, the caveat or the bad thing that people call out about this effect is that, well, without some sort of filtering mechanism, there's a low signal to noise ratio. There's arguably more crap than anything else. And in fact, this phenomenon may make it more difficult for us to find high quality things, because now there's this fuzz that we have to get through. And so we'll talk about that just a little bit, but it's something that that one has to be keenly aware when you're talking about the pros and cons of this shift. Now, just to be clear, one way of visualizing this is, your sales and popularity are characterized here, and the number of producers that realize those numbers is over here. So this is a sort of like a smoothed out histogram. And the thing with long tails is that as you aggregate and sum over this thing right here, it turns out to be heavier than that. Okay. Now, the major themes of this point are that, as it states right here, long tails are found in content, commerce, and community, and all these different things, because we see power laws there, and the tails themselves are gradually appearing to be heavier than the head themselves. I'll claim that one reason why we see long tails is that the physics of the online world differs from the offline world. I'm putting physics in quotes here to mean that I'm using this a little bit metaphorically, but here's a couple of examples how the physics differ. So the size of the warehouse for digital objects and shelf space, it's irrelevant. Okay, it doesn't matter, because if you're selling a digital object, your warehouse is your hard drive. The distance and the medium are irrelevant as well. You can have sales around the world or next door. Aggregation, remixing, and tagging all contribute to the collective pool of digital content. So I could be a blogger, and I may not actually contribute so much original content. It is in fact the aggregation or the selective filtering that I apply to other news stories and smacking them together to make for something that's of new and novel value. And scale can increase independently of human action often with a lot of systems. So our implications here are that consumers are slowly becoming producers in this world. All right, we all start either explicitly or implicitly becoming content producers, even if while we may not be the musicians who are creating MP3s, we could be publishing our playlist, or in fact, merely listening to songs contribute some sort of information to the collective pool of preferences that people seem to have for music. And in combination, as I said before, the small producers start to outweigh the large. So, part 3 of 4, ecosystems and network effects. By an ecosystem, I simply mean that you have this fertile economy or marketplace by which you can have a wide variety of participants of all sizes. So there is room at the top for the big players. There's room at the bottom for the very small players. There's room everywhere in between, and there's room for all sorts of intermediaries and value-added resellers in some sense of taking content of different forms and remixing it and whatever. And we've talked about a lot of this already, but just to kind of hit home with it, all these different things start adding to this collective pool of content, adding new value. Now, the reason why this gets very interesting is that network effects actually can start to happen when you have critical mass of participation. And so to just define some terms here, a network effect is the phenomenon by which your participation makes my participation more valuable. We see direct network effects in things like telephones and instant messaging graphs, and that's very easy to understand because the utility of me having a telephone is really related to how many people could I potentially call. And the more people who have telephones, the more utility it has to me. Therefore, there's some nonlinear value that is created that grows non-linearly in terms of the number of participation. There are also indirect network effects, and operating system development platforms are sort of the canonical example of that. Users use an OS because it has the most applications available for it. Developers write to an operating system because it has the most users. So these two different phenomena mutually reinforce one another. So it's not a direct network effect, it's an indirect network effect. Nonetheless, it has some durability. Now, why this gets really interesting in combination with ecosystems and other things is because we start seeing the whole being greater than the sum of the parts. So more explicitly, I talked before about content, commerce, and community. Having a network effect in commerce whereby you actually get some sort of very positive, mutually reinforcing dynamic, like, for example, that exists in the paid search industry where advertisers flock to AdWords because it has the biggest volume of traffic. AdWords translates into a very successful syndication product in the sense of AdSense because it has the most numbers which lead to the highest monetization. That in turn reinforces the amount of traffic and inventory of things that advertisers could buy to. That's an indirect network effect, and that's just for commerce. There's content ones as well that relate to file formats, that relate to publication platforms, if you will. Everything from XML, thinking about that as a publication platform in some sense. It's a language that becomes sort of the common language for certain things. There are network effects in community, as we talked about. Now, what gets really interesting is that these individual networks can actually start mutually reinforcing one another because, as an example, if we have some sort of critical mass in a network around content, all right, that becomes a way of characterizing what people like and dislike. Now, if you have a model of what people like and dislike, that translates into adding more value to the commerce ecosystem. Commerce becomes a way of propagating information signals about what is valuable and not so valuable in the larger ecosystem, and combining that with community where people are sort of expressing relationships between themselves and implicitly between the stuff that they like and dislike. All of that helps to make more sense of content. But now you have some measure of quality, you have some sort of measure of community filters, you have things like PageRank and all these other things. So these things actually start to mutually reinforce one another. So, put more simply and less elegantly, each is the chicken to the other's egg in some sense. So, and that lacking any makes the others less valuable, but in combination they're more valuable. And there you have it. So, part 4 of 4, the innovator's dilemma. Now, this is a topic that I think is probably the least familiar to this audience because this is a topic that is normally talked about by MBA types and within business circles and other things. So I'm going to give you a quick recap of what the innovator's dilemma is all about if you hadn't heard about it. It's actually a very, very fascinating book by Clay Christensen, and there's a follow-up called The Innovator's Solution, and it's been widely praised and had some criticism, but I think it's more worthy of praise than criticism. let me tell you the pattern that the innovator's dilemma is all about. The pattern is that the first company or entity within an industry focuses on the small number of high margin customers. All right, so when you take a look at the spectrum of the people that you could be doing business with, there's some small players, there's some big players. The big players you can typically charge more. Okay, they can sustain a higher margin business, and so if this is new fertile business territory, what I want to do is I want to have high margins, so I focus on that small number of customers just to kind of make my business more sustainable. Now, late arrivals in that industry, the copycats, the people who will come and follow me a little bit later, what they'll do is that since the innovator, the first in that industry, since they have focused on the really juicy customers, what they'll go for the scraps. And the scraps are the smaller customers that didn't really warrant the innovator's attention. You know, the smaller customers that perhaps don't have as high of a margin. Now, in order to survive, okay, it's harder to make a living focusing on those smaller number of customers. So what you do is you have to actually learn how to have larger scale and greater efficiency so that you can eke out a living. Now, what happens is across the board, both in terms of big customers and small customers, competition starts to heat up, right? And margins are shrinking across the board. So as with any other ecosystem, when there's scarce food supply or anything, you start to look for other sources of things to consume. So it's natural that the innovators, the guys who started off with the juicy, high margin but small number of customers, want to start thinking about how they can actually start selling to the masses. And the folks who started selling to the masses will actually start to think about how they can climb uphill and sell to the bigger players. Now, what's interesting is that the younger companies actually had to grow up learning bigger scale, tighter efficiencies, that sort of thing. And so it's easier to climb uphill than it is to go downhill. It's easier to take a business that focuses on large-scale, low-margin customers and translate that into a successful business for the smaller number of high-margin customers. It's really hard to take a fat and lazy company, to put it, not so gently, and turn that into something that actually scales and has high efficiency. So the pattern is that the late arrivals win because they can take optimizations and apply them to the head. End of story. So the dilemma, the whole reason why this book gets its title, is that if a company wishes to avoid this pattern, what they need to do is they need to kill their own business before someone else does. All right, and so the dilemma is that the first companies in an industry, the innovators, must eventually destroy their own business before someone else does. That's it in a nutshell. And the reason why is that the disruptions, the innovations, seem to happen where they're most needed, at this tail. So, there's really simple examples of where we've seen this historically. Back when I got my bachelor's degree in computer science back in the 80s, Cray was the coolest company in the world in terms of, like, if you were dabbling with going into grad school and you wanted an iconic company that really represented supercomputing, it was Cray, right? And by the time I started dabbling, getting into grad school, in the government research labs, Silicon Graphics was starting to eat their lunch in terms of sales, all right? And then Silicon Graphics was really had a lot of pressure from Suns. And I remember there was a time where every academic department in the world seemed to have Suns everywhere, Spark stations and the pizza boxes and everything. And then Suns seemed to be killed by the PC, And my question is the cell phone, especially when you take a look at emerging trends like in the youth marketplaces and in Korea and other parts of Asia, is the cell phone gonna knock Dell out of whack or something? And I think this is really fascinating that we've seen this, and we've seen this. I mean, this is just like a really poignant example for us, but this pattern has happened many times over. So my claim here, and this is really kind of putting the nice icing on the cake on the larger argument that I'll make, is that the innovator's dilemma is even more important in the online world than it ever was in the offline world. Now, we just talked about an example of the innovator's dilemma as applied to the physical world. And that took a couple of decades to really work itself out. From Cray to Silicon Graphics to Sun to the PCs really dominating everything to cell phones. And it's a story that's not even over yet. It's still evolving. It's taken decades. In the online world, it's like the clock cycle just got turned up in a big way. And for very, very simple, crisp reasons. Let's work through those. In the offline world, there's startup costs for new businesses that are actually pretty big. Okay, you have to have a sales force, you have to have a warehouse, you have to have some sort of, you have to have some place that you call your headquarters, right? In the online world, there's diminishing startup costs for new businesses. So everyone, you can put up a shingle and be online in no time. In the offline world, the aggregate size of the tail is limited by the physics of the world, right? So long tails really aren't that prevalent in the offline world as they are in the online world. In the online world, the aggregate size of the tail is potentially unlimited, right? So we're in early days of the internet. It appears that there's a long tail of content creators just in terms of HTML. That's only going to get bigger, that gap between the long tail and the head. Offline, more business usually implies more employees. So your fundamental scaling constants are tied to human effort. You have to work harder to make more money. Online, more business may not require more employees, and it may be that you just have to work smarter. Slight twist of a business model, slight way of finessing, where your variable costs reside, all those sorts of things. Offline, a quality product usually implies high touch, more involvement. Online, quality product can be a better algorithm, this intangible thing. Offline, innovation iteration follows product and business cycles. And like we talked about before, the product and business cycles just of the hardware world are still playing out. Online, the innovation iteration cycles follow data flow instead. And when your transactions that are occurring in this marketplace are all these ephemeral digital events, you're not bounded by physics, and these things can actually happen quite fast. So what I want to do is I'm going to hit pause right now, and I'm going to tell you a personal story from the history of the internet circa 2002, 2003. Now, in this time, before I came to Microsoft, I was the chief science officer of a company called Overture. And I don't know if any of you really remember what Overture was or is, but I like to think about it as the company that saved the internet, because it was the company that came up with the stupid business model that everyone thought was ridiculous, that has later been copied several times over and has made Google and Yahoo and other companies billions of dollars. Okay? That business model is called paid search. And so the paid search business model, as introduced by Bill Gross around 1999 or 2000, was the following. Let's have a search engine where the order of the results is determined by the willingness of someone to pay. So the higher that someone is willing to pay on a per-click basis, the higher they appear in the result set. And everyone looked at this business model and said, that's the stupidest business model in the world. Well, right now, it's making about $10 billion a year, and it's Google's biggest, almost entire source of revenue. They make this much from paid search, and that also is syndicated in AdSense, but it's pretty much the same engine. They make this much from their appliance sales and stuff like that. Same thing for Yahoo, same thing for MSN. It's a big driver of all of the internet being profitable today. Now, Overture invented this business model, and when we invented it, there was universal agreement that it was a stupid idea. And so when you are starting off with something that is universally agreed to be stupid, what you have to do if you're going to try to turn this into a successful business proposition, you actually have to have transparency in terms of how you operate. So we made a number of decisions that impacted our architecture, that impacted our business process, that impacted how we structured our sales force, that were designed to make things more transparent to increase the likelihood that the business model would be accepted by people who doubted it. So let me tell you about some of those decisions. Instead of using any sort of approximate match for search, we did exact match only. So if someone typed in flowers, the advertiser had to have explicitly said, I will bid on flowers. If someone wrote in buy flowers, that wasn't a match. We only did exact match because we needed that level of fine-grained control for the advertisers to have a comfort level around what we were doing. We also put in place hundreds of human editors. Just local in the Pasadena area, we had over 100, and then outsourced around the world, we had even more. So we had many, many human editors that were reviewing every single little search result before it ever went live on any site. And we had to do that because people were saying you're going to get crappy things, so we put this whole editorial process in place. We focused on doing deals with Yahoo and MSN and AOL, so big players in terms of how we would syndicate these search results to get more scale. We focused on getting relationships with online advertisers that were relatively big players. And so we typically had a high-touch customer relationship with all these players. We did a number of other things. And I think you're starting to see the pattern of what I'm talking about. Whether we're talking about syndication partners or advertisers that we courted, or the matching technology, or the fact that we use human editors for quality control, all of these things were an approach of focusing on the head, okay, because that's where the business was. Now, this company called Google that everyone knows about saw this model, said it was good, okay, but we can do it better. And so let me just tell you what happened. The short version is that they really kicked our ass. What they did was they said, this exact match, I don't know, let's do it approximate. So when someone types in, where can I buy flowers in Kalamazoo, Michigan, we'll just serve it when the advertiser asks for flowers. Doesn't matter that they're not in Kalamazoo, Michigan. We'll let some algorithms kind of figure that out later on. Instead of having human editors up front, they use click-through rate to do the filtering, to do a lot of the heavy lifting in terms of the editorial process. Instead of courting big advertisers, they said, it takes you 5 minutes to set up an account, self-serve, everyone gets on board, your ads are live in 5 minutes. Okay? So low touch, massive scale, going to the mom and pops of the world. Yeah, they did steal AOL from us, and that's how they got some big scale early on. But they also, on the part of having syndication partners, well, they did AdSense, and AdSense is basically turned about a 500,000 bloggers in the world into part-time or full-time bloggers in terms of how they make their money. And so, in every single way, when you work your way down this list, Overture focused on the head, Google focused on the tail. Now here's the thing. Around 2002 and 2003, we were kicking their ass. We were making more money, like many times more money than they were. We were out-monetizing them in the sense that if someone did a search on our engine versus on their engine, we made more money, our partners made more money. It was, life was good. What they did, though, was suddenly their click-through rate, forecasting, all this other stuff, was getting more data, getting more accurate. Suddenly, their semi-automated approach of using click-through rate for filtering is starting to surpass the quality of our human editors. Their approximate match on the queries was actually starting to have better results, better utility in the aggregate for the advertisers. Because now, if you wanted to get hits on our engine with, for 40 different types of queries, you had to enter in 40 different listings. For them, you just had to enter in one, flowers. Flowers got you almost everything. And same thing all the way down the line. They just got their efficiencies going, and then by the time 2004 hit around, they were just kicking our butt in terms of monetization and everything. So the rest is kind of history, as they say. But this whole thing, in 2002, when we were looking at this, we thought, we've got a good 2 years lead on them before they'll ever get within spitting distance of us in terms of monetization. And 6 months later, it was, we were like deer caught in the headlights. So that's a little bit of a little-known history of the internet, kind of, campfire horror story, if you will, making this case. So, back to the talk. The major themes here are, what I just talked about, is that, there's bigger bigger tail makes for more potential disruptions. It also makes for a much more rapid clock cycle because things are, to abuse a phrase, operating on internet speed. The implications here, and this is where I make a big leap. I'm going to claim that the process of societal evolution is itself changing. So let us now go to the internet singularity and kind of weave all this together into a more coherent story. And let's first recap the major 4 points. Democratization and macroization, that yields massive parallelization. So now everyone in the world is sort of an active participant in the ecosystem. Parallel distributions in the long tail, well, that makes, decentralization is bigger than centralization. So the size of the tail and the fact that all of this stuff is being distributed out with in a fairly self-organized manner is just, makes things bigger. Internet ecosystems and network effects, it makes the whole greater than the sum of the parts. So we're extracting out entirely new value in terms of how these things combine. The innovator's dilemma make for higher bandwidth and lower latencies with information flow and more frequent improvements because the clock cycle for change is actually faster. So remember this slide? We started off with science fiction, all right? And made the case for, not made the case, but I kind of gave some of the reasoning behind the original singularity, how it would happen. Let's make just a little subtle twist to these labels, all right? So instead of hacking the human brain, let's just say increasing human knowledge. So it's a little bit more grounded in reality. Instead of nanotechnology, which at its core is about the most fine-grained control on physical manufacturing or engineering that you can imagine, let's just talk about the ability of creating digital artifacts. So digital engineering or software engineering. Instead of talking about strong AIs and other things, let's just talk about the ability to analyze the online world. So greater sophistication in how we analyze those things. So the claim here is that the internet singularity is really about making for a tighter coupling between all of these things and architecting society in such a way that there is a mutually reinforcing effect between all of these things. And so the story is that as we make more knowledge available, through things like Wikipedia or, being able to connect to a broader social network or being able to have more sales or e-commerce that propagates information signals across the global marketplace, more human knowledge and the democratization of the tools that people use to, make use of that knowledge for creating new things, and ubiquitous computing and everything, it allows everyone to become a creator of new things. So we're increasing our ability to create digital artifacts. The more digital artifacts that are sort of put out into the cloud makes for an environment that lends itself to large-scale analysis. So I've been talking about music as sort of a simple but informative example throughout this talk. I don't have to be a musician and upload my MP3s to be a contributor. Merely all of us putting our playlist creates a set of data where we can actually start teasing out lots of different type of value from that data. So I can find people who like music that have similar musical tastes that I have. We could go another level up and say, what are the musicians and that are or the artists that seem to have audiences in common? We could do things like, what are of all the people that are deemed to be similar to me, what are the aggregate properties that we all seem to have? Are we in the same demographic, or do we only have some sort of career choices in common, or do we all have brown hair? Who knows? Okay, and you can work your way up into teasing out more and more interesting information because of the ecosystem. Now, the ability to analyze these things in a more sophisticated way allows us to actually tease out new knowledge and information. And search engines become one of many ways that we pull this information out and make it available to humans again. So again, the life cycle is, I'm a human, not a musician, but I can upload my playlist. I've lowered the barriers to participation here. I've created a digital artifact. Everyone is doing this we can make collaborative filtering and recommendation systems that really start to capture what it is about musical taste. That becomes a way for me personally to discover new music, right? This is now, a well-grounded, and a lot of people actually experience this firsthand today who are using online music services, so this isn't science fiction. What's really, really fascinating is that this is happening, this pattern, about 1,000 times over on the web, and it's ramping up. Now, and I'll talk about that, some more grounded examples in just a minute, but what I think is really fascinating is to think about, we're talking about a different type of adaptation. And, biology has evolution, society has culture as a way of filtering, refining, and propagating information. Economics has trade as one way for adaptive mechanisms to take place. Biochemistry has self-regulation in terms of gene structures and also biochemical reactions. Immune systems have adaptive mechanisms that start to resemble things like evolution. Brains have learning. Science has the scientific method. My claim is that there's another thing coming up on the list here that is very much consistent and yet complementary with everything that's already on the list. I don't know what it's called, but I think it has a lot to do with computer science. So let's talk about that. And to kind of set up this last point, I want to start with a joke. The joke is, engineers study interesting real-world problems, but fudge their results. However, mathematicians get exact results, but study only toy problems. Computer scientists, being neither engineers nor mathematicians, study toy problems and fudge their results. That's the only joke I've ever written, and I'm kind of proud of it, actually. So it's, I'm a computer scientist, so I'm allowed to poke fun at myself. But let's analyze the joke a little bit, and take note that the joke works if you start substituting an empiricist or experimentalist for engineer. People who deal with the messy real world. Mathematician for a theorist or an analyst or someone who's crunching equations. All right, and then you substitute computer scientist for a simulationist. I'll make up a word, simulationist. All right, someone who is somewhere in between those two worlds. Now, the important point that's hidden here is that simulation is a form of experimentation in a universe of theories. All right? If you're building simulations, you're simultaneously having one foot in the world of empiricism and analysis or theorization. So what happens is that there's this general process of iterative refinement that we see in lots of different domains. In publishing, you write a book, you publish it, you get reviews, and that informs the next thing that you write. And software, in the software industry, you code, you launch the product, and you get bug reports or feedback, and that kind of informs it there. In science, you have a hypothesis, you perform an experiment, then you use some level of analysis to reinform that. So there's these iterative loops. My claim is that simulation is somehow kind of like there's an element of capturing that entire batch process into one that's actually continuous. Now, let me tease out another part of all this. When you start thinking about the evolution of the internet, it starts looking a lot like a funhouse mirror of the world. All right, not completely accurate. Some things are distorted and compressed and don't really look like reality, but it still bears some resemblance to reality. And then that those relationships are actually getting much tighter. So, one claim is that as its composition participants, start maturing over time, this sort of, I don't know if it asymptotically approaches, but it gets closer. And I'll claim that where we're heading is that the physical world will gradually start to become instrumented in some sense by the virtual world. So if you have questions about how does the physical world work in some way, you may in fact be able to do the simulation experiment that is running on top of the virtual world. In this world, theories will be tested relative to internet data. Empiricists will have more data than they've ever known what to do with. And simulations will truly allow us to have this experiment in a universe of theories. So in this in this grand scheme of things, we're changing the labels one more time. And instead of human knowledge, we're talking about scientific knowledge. Instead of creating digital artifacts, we're just talking about engineering. And instead of the ability to analyze the online world, we're just talking about mathematical analysis. In this world, these things mutually reinforce one another in a much more liquid manner, and a thing that's much more continuous instead of batch. So the more we know about the universe, the more that we can embed online about that knowledge. The more knowledge, and this takes this reflects itself in terms of databases or data sources or applications and other things. Now, the more that's embedded online, the more that's available for very broad analysis. The more that's available for very broad analysis, the more facts about the world we can tease out. And this reinforces one another. So let me tell you some existing evidence that this is actually becoming much, much more important. So natural language processing 15 years ago was kind of stuck for a long time on these handcrafted grammars. Finally, someone said, wow, there's a whole bunch of several corpora online that I can actually take and analyze them and see what the statistical properties are between words and n-grams and things like that. And now we have statistical NLP just dominating. And all sorts of things like machine translation have basically had a renaissance because of this, using online data to change the scientific field of discipline. We're seeing virtual worlds are now being used to study emerging economies in a very real way. People are actually doing experiments in terms of how people use, how their utility functions in a marketplace change and evolve and are a function of their identities and all these things. We're finding that viruses, Trojan horses, all the security things that we struggle with are now a legitimate way of studying trends in epidemiology, how you actually study the spread of things. My favorite example, and I use this in the past tense, and this has already happened actually. The National Institute of Health has done this wonderful thing. They started off with putting all the human genome data that they had online in this really beautiful digital archive where you could browse by the name of the gene sequence and its properties and see a list of what papers cited that gene sequence. And so this was a really nice tool because academics, instead of going through some painstakingly complex way of referencing what gene that they were talking about or what DNA sequence, they could just reference the entry into this archive. Now, the next step that then NIH took is they said, okay, we're actually going to make now an online repository of the literature that references this database. So now it's a completely sort of hyperlinked aggregate database where you have the scientific literature making references to the gene sequences. You click on the gene sequence, you can see what paper cite it. You can now jump to another paper and so on and so forth. And then they said, oh, well, let's take this another step. Let's see what happens when we open up an API so that web data miners can actually start looking at these patterns. And what has happened is that data miners looking at these properties discover that hypotheses are often articulated with very simple and consistent language. Questions, same thing. Statements of fact, same thing. Very regular language. And taking an approach where they've looked at the forest and discerned patterns in all the literature and in everything that was known about these gene sequences, the scientific discoveries have actually been made through data mining of these online repositories. And so this is, I think, a really crisp example of how the scientific method actually changes as a function of all this. So, and this is kind of like a plug for what we're working on. I'll claim that web search is now, in some ways, the greatest applied CS/R&D problem because it'll drive priorities in AI, programming languages, databases, distributed systems, all these different things. It's something of a touchstone how all these things converge at once when you do it on massive scale. And I think that we're not done with this problem until we've realized lots of the promises of AI. So, final thoughts. Prediction is difficult, especially the future, attributed to multiple people. But the best way to predict the future is to invent it. So, starting back with my subtitle of the talk, I offer you just a statement of optimism about what a great time it is to be a computer scientist. That's it. Thanks. So you think we got 4 minutes or something, or yeah? Hello, Eric.
So I think it's quite interesting that I see the kind of connection with what you talk about and the kind of first talk about dynamic languages or yesterday's, where you kind of see the kind of same thing with the long tail and the innovator's dilemma, where the kind of static languages are kind of going for the high end, where the dynamic languages are going for coming up from the bottom.
Well, I think I had a little bullet up there, and maybe it's deserving of a bigger bullet. Visual Basic kind of democratized programming for a lot of folks, and Excel macros and things like that. And I think we've only it's really fun. It's really interesting to watch because there's been sort of this. There's been sort of like an expanding and contracting in terms of the amount of work it takes to do things. I'll claim today that Ajax is a train wreck as a programming framework, and that we should be embarrassed by it. But thank you. Okay, it's a train. Here's for the train wreck. When we go for, I think dynamic languages will be a really great. You and I actually had a thread about this a couple days ago about why does web development suck so much that I have to actually code in 5 different languages to make one application, and those 5 things have to be deployed, in multiple places. That's a horrible place to be. And I think obviously there's going to be something much better, and I think something that takes some of the great elements of both dynamic and static languages will be a great way of making for a more liquid environment and applications. Oh, yes.
Douglas Adams suggested first that Earth is one big simulation. You just mentioned the simulation rate. So
yeah.
Maybe you want to give him credit.
So, I'm sorry, who said that?
Douglas Adams.
Yeah. Okay, yes. I'll do that in the future.
What does it mean, the tails concept for software development and operating systems? Like, say, for example, we used to have, right now we have 2 dominating languages, and there's Ruby and, all the other new languages coming up. And the same in the operating system space. What does it mean for operating systems?
Well, I mean, I think that's I think that's a great question. And right now, clearly, what's that?
What was it?
Oh, I'm sorry. The question was, thinking about the long tail, what does this mean in terms of programming languages and also operating systems? And so I'll make a general claim that the head of the operating system universe is Windows. I don't think that's too controversial. And the tail of operating systems, I think superficially people might say it's Linux. I actually think it's really the web. Okay, the web as a platform for new applications. I think that's the tail. And I think, and if you think about Microsoft's emerging strategy into moving more from just software into software plus services, that's in recognition of that. From a development platform point of view, I think you're absolutely right that there are certain. I don't know that it'll follow a strict, rigorous power law distribution, but clearly, things like C++, C#, Java capture a lot of mind share, and then Perl and other things, and then maybe there's I don't know if you characterize these by the size of the projects or whatever. Who knows? I mean, I don't know how to even quantify that. It wouldn't surprise me if there's more, I don't want to say amateurish languages, but more kinder, gentler, lower startup cost languages that actually account for a larger number of small projects, that sort of thing. So, hey, have any of you seen, I have a question, who here has seen the Photosynth tech preview? Ah, damn, I should have shown that. So the Photosynth tech preview was the first project that came out of my team, which is Live Labs. And the reason why I'm citing is that when I start saying the internet starts being a way of instrumenting the physical world, it sounds like bullshit. But when you take a look at Photosynth, you start saying, ooh, this might be possible. We have a technology where we can take a mess of photos that no humans have touched and figure out how they spatially relate to one another, then construct a 3D model from that, and then give a seamless environment how you can interact with that photo universe. So we're going from slideshow being this linear presentation of slides or a photo gallery of just a grid to being an immersive 3D environment. So this whole thing about, so this is a story about how tail participation really makes this thing take off. It creates a digital mirror of the physical world. It lends itself for discovering new things about the world that you never would have. And if I had more time, I'd just show you the video of it.
Well, we have a break coming up. Why don't we show it during the break?
Okay, we'll do. We'll do. Yeah.
So there's a potential counter argument with the kind of technology long tail thing.
Yeah.
Which is that long tails work really well for music because audio files are audio files. Some people like this kind of music, some people like that other kind of music, and we can all like different songs and we can all like different bands, and it doesn't matter, and there can be a bazillion niches.
Yeah.
But with technology, there are network effects involved. So Java is valuable because there are a bazillion people programming in Java.
Yeah.
And the fact that we can all interoperate with each other and so on is a big part of it.
But there's a network effect in the music as well that you're ignoring.
Well,
so there's file format, there is the format of the playlist, there are things like CDDB for consolidating, the CDDB is like pretty much community effort to figure out how do you actually rip a CD and extract a playlist from it automatically.
Right, so we're saying that the technology is actually, whether it's a file format for the MP3 or WAV file, or like the CLI or Java, is actually the thing that enables the long tail. So the long tail of software is actually kind of potentially libraries and applications that can all be plugged together.
Yeah. And web APIs and things like that actually take that to a whole different level, because the level of abstraction of what you're encapsulating now becomes, in some sense, layer weight, number one, because it's now only talking over an HTTP connection, number one. Number two, the thing that's on the other end, it could be a search engine. Okay, so we're effectively giving a subroutine that realizes a search engine to programmers, which is a pretty amazing thing.
Right, but I think we may be heading down the wrong analogy here if we start going, there's a long tail of technologies, starting with the JVM and the CLI and going down through Ruby and blah, 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 blah. I don't necessarily think that's the case. I think that actually what will happen is that there will be, there's a big reason, due to networking effects, that the JVM or the CLI end up being the MP3 or the WAV, and that the actual long tail of software is the tiny little millions of...
Yeah. I think that's a fine interpretation of it. I wouldn't really contest that. So I think that we're over time. Thank you for having me. I will get a network connection, see if I can queue up this video for those interested during the break. Yeah, thank you.